Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we will be continuing the JAM 2019 paper, okay, that we were solving since the last three videos, I guess. Okay, so yeah, so in the last video we did up till question number 15, and therefore we will be starting with this video from question number 16. Okay, so yeah, so the question number 16 says that the ratio of the nearest atomic distance in the body centered cubic and the face centered cubic crystals with the same units edge length would be. Okay, so the relation for the edge length and the radius and the distance between the two unit cells is given as for FCC. Is the pointer? Yeah, for FCC we know A is equal to 2 root 2 R. Okay, and for BCC lattice A is equal to 4 by root 3 into R. Okay, so you are asked to write the ratio of the BCC divided by FCC. Okay, so ratio for A of BCC divided by A of FCC is equal to 4 divided by root 3 R divided by 2 root 2 R. Okay, R cancels out over here, 2 is cancelled out over here. Okay, so yeah, so what remains is 2 root 2 divided by 2 divided by root 3 into root 2. Okay, or we may also write this 2 as root 2 into root 2. Okay, so the proper answer would be root 2 divided by root 3. Okay, yeah, so the option that is obtained is root 2 divided by root 3. Okay, so in the options you can see that question number 16 has the different option, obviously, that is root 3 divided by root 2, but that is just because of the ratio that we have done. Okay, so yeah, so the option here would be option A equal to the answer, which is the correct one. Okay, yeah, so moving on to the next question over here, we have two, that is the correct trend in the rate of substitution of Cl minus by pyridine in the following complexes. Okay, so we have to substitute the Cl with pyridine for four complexes that are given. So let me draw the four complexes. Okay, PET3, uh, PET3, CH3, PT, Cl, PH, PET3 and PET3. The other complexes PCl, Cl, PET3 and obviously PET3, and the last complex that is drawn is PT, Cl, PET3, H and PET3. Okay, so these four are the complexes that are given. Okay, so let us name them 1, 2, 3 and 4. Okay, so we have to substitute pyridine, substitute chlorine by pyridine. Okay, so depends on the PTCl bond, how the stronger the PTCl bond, and the greater would be the difficulty in substituting. Okay, so obviously you can see that in the for firstly the option number 4 would be having the highest difficulty in releasing the PT. Why releasing the Cl and introducing PT? Because here the main effect that is being that monitors the substitution is the trans effect. Okay, trans effect. Greater the trans effect of the group in the trans to the group that in the trans to the ligand that is being replaced, greater will be the rate of substitution over here. Okay, now H in this case it has the has no trans effect, obviously. Oh, and obviously this is like a very small ligand, and therefore the removal of chlorine and the addition of pyridine would not be having any sorts of difficulty. So this fourth complex would be having the highest rate of highest rate effect of substitution of the chlorine to the pyridine. Okay. Now in the the next structure that would be, that is 1. Okay. Now 1 has a bit highest trans effect over here, and therefore it would direct the Cl, it would leave the Cl, and the pyridine that is coming, that is the incoming pyridine nucleophile, would be attached to the attached here at the trans position of the methyl group very easily. Okay. So after then the I would be there, and then the next option would be the 2 1, that is the pH. The pH has also a good amount of trans effect in the system, or because obviously and it would, like the incoming ligand, that is the pyridine group, would be attaching removing the Cl and getting attached to the PT center quite easily. Okay. And the last one, that is the Cl. Now Cl and Cl, both of them has the equal level of trans effect, so they would nullify each other, and therefore the rate of substitution of one of the Cl is decreased by pyridine is decreased. Why? Because the no trans effect is observed in there. Okay. Because Cl won't replacing Cl, the other Cl won't be producing any trans effect as such. Okay. The details of trans effect, obviously I'll be explaining while I'll be teaching the coordination chemistry part, so that part will be keeping for that case only. Okay. So in the options, you can see that option A is the is this trend which is given in the which I have just drawn. Okay. I'm sorry, this is question number 17. Okay. Yeah. So option A, is the correct option over there. Okay. Moving on to the next question, that is question number 18. Okay. In quantitative inorganic analysis of metal ions, the ions which precipitate as sulfide in the presence of H2S in warm dilute HCl is. Okay. Now, firstly, you have to understand that the H2S in warm dilute HCl, is the reagent for group 2 in the group analysis. Okay. For the group 2, specifically for group 2A. Okay. Now if we take like the options that are given are chromium, this belongs to group 3, aluminium, this also belongs to group 3, cobalt, which belongs to group 2B. Okay. I guess 2B or 4, I don't remember exactly. 2B. Okay. And bismuth, Bi3 plus. Now bismuth is the only compound which belongs to group 2A. Okay. And therefore while precipitating bismuth, bismuth, as it is in group 2A, so the H2S in warm dilute HCl would precipitate the bismuth ion quite easily than the rest of these compound. Obviously chromium will also get precipitated if the concentration of H2S is high, but here the concentration of H2S is checked because of the HCl, that is the common ion effect that we all know. Okay. So the release of H2 minus ion is suppressed by the presence of HCl, and therefore at such low concentration, aluminium or cobalt or chromium would not be precipitated so easily, but bismuth can be. Okay. Bismuth requires a low, the ionic product of bismuth sulfide is very low, and therefore it can be precipitated and that is why the bismuth ion is in the group 2 elements. Okay. Yeah. So in the options, bismuth is in the fourth option, so therefore bismuth is the correct answer. Option D is the correct one. Okay. Moving on to question number 19, that is the correct statement regarding the observed magnetic moment of NO, O2, B2 and C2. Okay. So we are talking about magnetic moment. Okay. So in the O2 orbital, as you all know, there are obviously in the 2p, when the 2p orbitals overlap to form a molecular orbital, this kind of substance, like this kind of orbital is formed. Okay. So here would be 1, and this would be going. Here would be these 2, and here would be 1. Okay. These are the px, py, pz for the 2 atoms that are attached. Okay. Px, py, px. Okay. Anyways, so NO has number of orbitals in the number of electrons in the p orbital of N is the atomic number N is 7. So 2s2p occupies 4 electrons. So 3 are there. Okay. 3 are there in N, and 4 of them are there in oxygen. Okay. Okay, so 3 plus 4 will be equal to 7. So 2 electron would be over here, 2 electron would be over here, and yeah, and 1 electron would be over here. So this has one electron missing, so 1 electron unpaired. So the NO would be paramagnetic. Okay, now O2 also has a total of 8 electrons. That is 7. That is this must be 4. Okay, so 3 plus 4 equal to 7. Now O2 has 4 plus 4 in the p orbital, that is 8. So O2 will be having 2 unpaired electrons, and that is also like both of them are unpaired and therefore paramagnetic in nature, and therefore yeah, so this would be the case. Okay, so paramagnetic in nature. Now B2, let us talk about B2. What happens in B2 is B2 has B has 1 electron in the like B has a atomic number 5, hydrogen, helium, lithium, beryllium, boron. Okay, 5 to 4 of them are occupied by the 1s and 2s orbitals. So 1 electron is there in the that orbital, like the p orbital. Yeah, in the p orbital. So B2 obviously has for B2 the structure is kind of changed as the pi orbital moves downwards. Okay, the pi orbital moves downwards and the sigma orbital is upwards. Okay, so for B2 we have 2 electrons only, one from each B, so 2 electrons are there, and therefore 2 electrons have the same in the same degenerate state. They remain as following Hund's rule, they remain as unpaired electrons. Okay, so here this atom would be paramagnetic also. Okay, now in case of carbon, what happens is that we have 2 plus 2, 4 electrons in the system. Okay, so this electrons get paired up and makes the system make the C2 system diamagnetic. Okay, so this is why C2 is not C2 is diamagnetic, and B2 with the pointer. Yeah, so B2, O2 and NO are paramagnetic. Okay. So in the options you can see option B says B2, A2 and NO are paramagnetic. So option B is the correct option. Okay. Moving on to the last question of this video. Okay. So the observed magnetic moment of Mn, Fe and Co complex are 4.95, 6.06 and 0.0 bm respectively. The correct option for the electronic configuration of Mn, Fe and Co would be. Okay, so we are talking about the Bohr magnetic moment. So in the like if you just we know that if nothing is mentioned, then we will be considering the mu SO value, that is the mu magnetic moment spin only value. Okay, so this we know the formula is n into n plus 2, where n is the number of unpaired electrons. Okay, unpaired electrons. Now we have the calculator with us. So the first value that is given is for Mn2 Mn3 plus the value that is given is 4.95. This is equal to n into n plus 2. Okay, so so let us square this. What we will be getting is 4.95 4.95 into 4.95. So we are getting 24.5. Okay, yeah, so 24.5 is the value obtained, which is equal to n into n plus 2. Okay, so if we have 24 over here, then what would be the n into n plus 2 value? If we say 4 into 6 is equal to 24, then the number of unpaired electron would be 4. Okay, so let us say we do root 24. Yeah, so obviously if this value is if like approximated to 24, then n can be equal to 4. So n into n plus 2 would be equal to 6. 4 into 6 will be equal to 24. So for Mn3 plus, the n would number of unpaired electron is 24. So in a similar way, let us calculate for Fe3 plus. Fe3 plus, the value is given to be 6.06. Okay, so 36 would be equal to n into n plus 2 approximately. Okay, 6.06 into uh, 6.06 is equal to 36.7. Okay, so 36.7 is equal to n into n plus 2. If we like translate this into we say what should we say, so 36 if we translate the value, then what we'll be getting is if we say 30, not 36, if we translate the value like round up the value 35, we'll be getting that n is equal to 5. Okay, so 5 into n plus n into n plus 2, that is 5 into 5 plus 2, that is 5 into 7, which gives equal to 35 value. So obviously the deviation from value is because the question does not consider the mu SO value, it considers the mu S plus L value. Okay, so that is why the deviation is occurred, but we'll be calculating on the basis of mu SO, and therefore we'll be plotting the energy diagram. Okay, so this has 4 unpaired electrons, these are 5 unpaired electrons. So let us now plot the energy profile diagrams. Okay, so Mn3 plus is scandium, titanium, vanadium, chromium, manganese. Okay, so D5 and 2 electrons over there, so D4, 3D4 system. Okay, so this if this configuration is followed, then this would be having 4 electrons, that is this is Eg, this is T2G. Okay, this is T2G, this is Eg. Okay, T2G has 3 electrons, Eg has 1 electron. Similarly for Fe, here we are saying Fe3 plus. Okay, Fe3 plus, so 3D5 system is followed. Okay, um, yeah, so 3D5 is followed obviously. So yeah, 3D5, if we draw the diagram, we get 5 electrons need to be unpaired. Okay, so 5 of them in the low spin complex, the high spin complex, obviously this would be the case. So here we have Eg2 and T2G3. Okay, in a similar way, if we write down about cobalt 3 plus, cobalt 3 plus has the 0.00 Bohr magneton, that is all of the electrons are paired up, there is no unpaired electron left. Okay, CO3 plus is obviously having the D6 configuration, and therefore electrons if being paired up, we have low spin complex, that is this kind of. Okay, so the configuration would be for Mn3 plus, it would be T2G3, T2G3, Eg1, and for this one, for Fe would be T2G3, Eg2. Okay, and for CO3 plus would be T2G6 and Eg0. Okay, now in the options you can see that this option is given in option number C. Okay, option number C. Yeah, option number C. Okay, so option C is the correct one. Okay, so thank you guys for this video. Let us wrap it up, and we'll be continuing the further in the next video. Okay, so thank you.